All right, so let's jump right into the notes so I can let you guys get your homework done. On Monday, after we went over the syllabus, we talked about a bunch of terminology. So now we're going to actually use that terminology to do some things. So it's okay if you pull out your notes while we're, well, obviously we're doing the notes here, but to refresh our brain about what the different terms mean. So first up, we did example 1 in class on Monday. I think everybody was good with that. Did your screens all pull up? Okay, there we go. So let's do problem number 1 and number 2. And I know in my notes, like there's example 1, problem 1, 2, all that. So it's just because I pulled this from other places. It's not always going to be nice and neat, unfortunately. So let's open this up in Paint. All right, here we go. So the first thing says, name 3 points in the diagram that are not collinear. So the first thing to remember is, what does collinear mean? So if you remember, we talked about, we talked about points, lines, and planes, right? And we talked about collinear. That word has the word linear in there, which is like a line, right? So collinear points mean that they are on the same line. So what they're asking is, name 3 points in the diagram that are not collinear. You'll see they have this nice box drawn out for us. And this actually should be pretty easy, right? What if we wanted to name 2 points that are collinear? There's lots of choices for that, right? We could say that right in the front, point A and point D are collinear because they're on the same line here. We could say A and E are collinear. E and F are collinear. There's a lot of possibilities. Basically, all of the edges of this box are collinear to each other. But what they ask is 3 points in the diagram that are not collinear. So there's more than one solution to this, but let's just kind of be crazy here. We'll say we got point A here, right? Let's pick point H down here. That's not on the same line as A, right? And then we could pick point F back here. So one possible solution would be A, H, and F. So write that A, H, and F. There are many, many solutions to this. There's many combinations of points that are not collinear. Okay? That makes sense? Pretty easy? Good. All right. Name the point in the diagram that is coplanar with points A, D, and E. So before we were talking about collinear, so you have that word line in there, right? Coplanar, we're talking about the plane. So when you talk about a plane, it's in 2 dimensions. So the easiest plane that I can think of is a sheet of paper. That's a plane, right? It's nice and thin. It's in 2 directions. So they're asking us to name another point in the diagram that is coplanar with points A, D, and E. So the plane that they're talking about is basically the front of this rectangular box, right? They've got A, D, and E. So what would be the other point that is coplanar on the same plane? How about H? H, right? H is on the same plane. So that's all you have to say is H. Pretty cool, right? So exciting. All right, I actually like example 2. I think it's kind of fun to do. And it's the purpose of it is to kind of practice what these different symbols signify when you're drawing it. Okay, so it says draw 4 non-collinear points A, B, C, and D. So they've already drawn A, B, C, and D for us. Isn't that nice? Then draw line segment AB, ray BC, line CD, ray DA, and ray BD. All right, so I said what all those were, but let's see if we can remember from Monday what they actually mean. So the first step, we have draw line AB, or line segment AB is what I should actually say. So you'll notice that when they've indicated AB, there's no little arrows going either way, right? So this indicates that it's a line segment and that it starts at A and ends at B, or starts at B and ends at A. Either one's okay. So when we draw a line segment from A to B, we're going to do something like that. And we know it's a line segment because there's not these little arrows over top. Okay? So then next up we have BC, and it's a one-way arrow. So what does a one-way arrow mean? Well, one array, exactly. And the ray starts at B and goes through C. So remember, ray is the only one it matters what order you write it in. So this means that it starts at B, goes through C, and it keeps going. So if I'm going to be fancy here, it's going to have a little arrow at the end. Okay. Now, next up, we have CD, and this is a line, and it's got the arrows going both ways. So what that tells us is that it's a line, not a line segment. And what I mean by that is if we connect C and D, I actually have to start a little higher. Oh, that was bad. Hold on, I was trying to freehand that. I should not have done that. All right, here we go. Try to be nice. C and D. Do it that way. There we go. So this particular one is a line, which means it goes on forever and ever. And I know this seems like easy stuff, but once you get into geometry, they're going to throw around like line segment, ray, blah, 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 and they just expect you to know what that means. So that's why we're, taking a bit of time to do that. All right, so I'm going to do it in like 1 minute, but on your paper, try drawing DA and BD. And I'm purposely not saying what they are, but go ahead and try to draw those. I'm going to give you 1 minute to do it, and then you can check it as I draw it. All right, everybody get a chance to try it? Awesome. So these are both actually rays, again, because we only have the one-sided arrow. So we have ray DA. So that means we have to start at D and go to A. Not that one. I want the pretty line. Start at D, go to A, and keep on going. And that's going to have a little arrow right there. All right. Looks like a kindergartner drawing. And then we've got ray BD. So ray BD is going to start at B, go through D. Not like that. It's going to look something like that. And it is going to have an arrow at the end. There's probably a tool for that. Okay, so that's how you would do that, drawing those segments. And then there was one last example on there, which I think is pretty easy. It says, draw a line, label 3 points on the line, and name a pair of opposite rays. So This is going to be an easy one. I already drew the line for you, right? So draw points X, Y, and Z on a given line so that Y is between X and Z. So let's just follow in directions. So we've got point Y. We've got point X. And we've got point Z. Maybe. There we go. So we have a line. There's 3 points on the line. We've got Y is between X and Z. So this is considered a line. And we want to talk about some opposite rays. So what are our two opposite rays? We have one ray that starts at Y and goes past X and on out. So that would be ray Y, X. And it looks like this. Okay. And then we also have a ray that's going this way. That would be labeled YZ. And these two would be opposite rays. And they also make the line segment. We could call this line segment, or line, just sorry, not line segment. We could call this line XZ. Like that. Okay. Any questions about that? I think 1-1 should be pretty easy. I was going to go ahead and do 1-2, but you guys get a pass since not everybody can even get on class. So I will have to figure that out. There is the problem 44, right? That was in the homework that I think Sophia asked about. And I think Kirsten asked about a problem too. So let me look at my, she texted me yesterday and asked me to do a problem too. Oh, she's ahead. She's in 1-2 already. Kirsten, are you online? Oh, okay. See, you guys are all so smart at this kind of stuff. I'll go ahead and do that one for her at the end, but if you guys aren't there yet, that's fine. Okay, so Sophia asked about number 44. So that is an even number, so you don't have the answers in the back, but I think we can do it. If you have your book, I'm on page 7. It says, a surveying instrument is placed on a tripod. The tripod has 3 legs whose lengths can be adjusted. When the tripod is sitting on a level surface, are the tips of the legs coplanar? Okay, so we're going to have to there's a picture there of a tripod. I'm going to try my best to draw something that's 3-dimensional, but it might not be very pretty. All right, so if you think of the ground, right? It's a flat plane, right? I know the ground goes on forever in all directions. So if you just think of the ground, do you think the ground is a plane when it's flat? What do you think? If you had a big flat field that was perfectly flat, would that be a plane? Yeah, right? Because a plane, I mean, if you're just talking about the top surface, obviously there's depth under it of soil. And I guess that was kind of a trick question, but there's, soil and earth and all that stuff. But we're just talking about the top. That's a plane, right? Plane is just 2 dimensions, like your sheet of paper, your wall, any of that, your floor. So big grassy field, sure, that would be a plane. So they're going to stick a tripod on a level surface, and they want to know if the tips of the legs are coplanar. So a tripod just means 3. If I can get my pen to draw. There we go. 2, 3. So if you kind of think of a tripod sitting there with its 3 legs down on the floor, on your, just think of it sitting on your carpet that's flat, right? Or your hardwood floor. So those 3 points, are they coplanar? I would say yes, right? Because all 3 points are lying on the plane, and the plane is flat, and that's the definition of a plane. So yes, those 3 points would be coplanar. So then it says on part B, of course, a little more tricky, right? Suppose the tripod is used on a sloping surface. The length of each leg is adjusted so the base of the surveying equipment is level with the horizon. Are the tips of the legs coplanar? Explain. So now all of a sudden, our tripod is sitting on a hill, right? And so this is kind of tricky to think about. Does anybody have a strong feeling right away? Okay, so the tripod is used on a sloping surface. So instead of sitting on this flat thing, now we've got a tripod, and this is the side view. If I can get my pen to draw. Before it was easy, right? It's all flat. It's definitely on a plane. So now, think of this is like a hill, right? And if it's in like a couple dimensions, this is another part of the hill, a ski slope. So now you've got your tripod set up. And it's kind of at 3 different points on the hill. So, and it says specifically, the length of each leg is adjusted so that the base of the surveying instrument is level with the horizon. So basically they're leveling the thing on the top. Are the tips of the legs coplanar? So I would actually say for this one that it depends. So you could have a case where your front 2 legs, like say, are level with each other, and your plane is actually kind of going up the hill. So you could have the front 2 are on the same plane. And then if you kind of think of this plane as sloping upward, because a plane doesn't have to be perfectly flat, it just has to be 2 dimensions. So if you had something like this, where the front 2 are on the plane and the back one's on the plane, then that could be coplanar. But I think what they're trying to get at is if you have like a rocky kind of a surface where you have, you know, one leg is one length, one leg is another length, and the third is a different length. So this would be something more like this leg's here, and maybe this leg's down here, and they're all at different levels. Then I would say that's not coplanar. So that's kind of one of those questions that's like, if you say yes and you say because if they're on, if 2 of the legs are the same, then they could still be coplanar. Or if you say no because they would all be different distances, so they're not on the same plane, either one would be okay. Okay. Kirsten was asking about number 27, which is on page 13. That's in 1-2, which we haven't actually done yet. So good for you, Kirsten, for being ahead on your homework. She said it was a star question, so it's a multiple choice and the answer is not in the back. I didn't realize the answer wasn't in the back. I don't know if it's in a specific area. One thing I did want to mention to you guys, I thought it would have been something different. In your homework, like if you look at page 12, if you have your book, number 13 and 17 actually have a red circle around it. So if you ever get to a problem that has a red circle, that means that the solutions are actually in the section of your back of your book called worked out solutions. So they've actually, for number 13, they don't just tell you the answer is what, I don't even know. They don't just tell you the answer. They actually work it out step by step. So if you're ever having trouble in a section, you can look for those circled problems, and those will actually give you the step-by-step how they got it, not just the answer. Yes, this is for that. So number 27 I can do. If you guys would like, if you haven't gotten there yet, you can just listen in, or you can go ahead and go for the day, but I'm going to go ahead and do that since I was specifically asked about that one. So if you're going to go, thank you guys so much for coming. I am sorry that the technology is not going to work for us maybe this year. So we will figure something out. So we might have a little time next week, but since we really didn't get through that much, we're just going to really, the homework this week is just going to be 1.1. But if you're ahead on 1.2, that's awesome. You can probably get through that pretty quickly. So if you're leaving, have a great day. If you want to stay on for number 27 of 1.2, you're welcome to do that. Okay. All right. So number 27 is a multiple choice question. It says use the diagram, and there is a line segment there. And we haven't actually kind of officially learned this yet, but I think you guys can all figure it out even if you haven't, and it would probably help on Monday as well. So what they have is a line segment. I'll actually use my tool to draw it. Okay, and there's a couple points on here. If I can use the right tool. There's a point here. This is point E. This is point F. And this is point G. So here we go. Spoiler, that's a crazy G, sorry. Spoiler alert for Monday. If you have, let's start off with something really easy. Well, let's start off with the right number here. This is 6. I don't know why it has that little loop on there, sorry. This is 6. Let's say that this is 10. We don't know what it is right now, okay? The length from E to F is 6 units, and the length from F to G is 10 units. What do you think the length from E to G is? It's not a trick question. It's 6 plus 10. It's 16. That's what we're going to learn on Monday, so, be prepared. It's going to be tough, right? Now, so basically, if you have, there's a postulate, and we'll talk about what that means, but if you have, it's called the segment addition postulate. So if you have one segment plus another segment, that equals the total segment length. All right. So there's a couple of problems that you'll do that are going to be super easy. Like, for example, number 7 in your book on page 12, if you have it, it says, there's a line and it says the distance from R to S is 22 and the distance from S to T is 22. So what's the total distance? Guess what you do? You add them together. 22 plus 22 is 44. So it's not too complicated. But when you get to 27, it's kind of near the end, so they're going to get a little more fancy, right? And we're going to pull out a little bit of algebra. So they tell us that the length from E to F is 6, and the length from F to G is X. And then they tell us that the total length, I apologize for my horrible drawing here. The total length is 1.6x. Okay, so we're going to do this the same way. It's just that they're going to throw some algebra in there at you. All right, so what does that mean? So that means that the distance from E to F plus the distance from F to G equals the total distance. So what that looks like mathematically is that 6 plus, and then X, right? That's not a B, that's a 6, sorry. 6 plus X equals the total length, which is 1.6x. So now we're going to bust out a little bit of your algebra skills if they're in there somewhere. This is your time to bring them out. If not, we're all right, right? So right now we have an x on both sides of the equation, and we need to solve for x. So in order to solve for x, we got to get the x's together. So we have an x on one side and an x on the other side. So we need to bring those guys together. So the way I'm going to do that is I have 6 plus x. So I am going to also subtract x from both sides. Okay. So what I'm left over on the left-hand side with is just a 6. And what I have on the right-hand side is, trying to get my pen to work, 1.6. It's not working. I gotta use my mouse. 1.6x minus x. Does anybody remember what's implied if you don't have anything in front of x? Just a 1, right? So 1.6x minus 1x just leaves us with, I know, is your brain like, oh, algebra? 0